So tonight we are going to hear from a range of professionals. So we'll kick off with Scott McAulay of Harsha Gore Mohit Buch, Pablo van der Lugt, and James, Todd, and Malachy McNamara. And I would like to thank our sponsors. We could not put on this challenge without them. They are Transforming Timber, Timber Decking and Cladding Association, Akoya, Wood for Good, PEFC, PH15, and Stora Enso and Rothablas. And we are supported by software partners too. In December, we kicked off with 9 professionals who set the scene. We were introduced to the software that teams will be able to use, and that will include SketchUp, Design PH, PHP, and a carbon calculator from the AECB. We met our clients, who are NMITE, Growing Local, and Belmont Wanderers. And we discovered what we are asking you to design in this challenge. And it is this building here, which is Southside, but please ignore the diagram. It is completely up to you what you design. Belmont Wanderers is a junior football club, and they have got some requirements that they need. So changing rooms, official rooms, accessible water closets, very old-fashioned term, community room, and I should have really highlighted that they so want a bar. There is no bar within the local area. They need a small kitchen, an office, and everything needs to be to Sports England standard. Growing Local are a community group who not only grow vegetables, they teach people to cook. They are looking for a passive house building that is obviously sustainable. They want it to produce more energy than they will use, and it needs to fit in with its rural environment. They just screen grabbed these buildings. So yeah, they are completely up for whatever you would like to design. They run a cook school, so they need a classroom with enough for 10 units. I think it's 30 students they plan to hold. They also want a non-food classroom, a catering kitchen, a farm shop, and a cafe, along with all the other facilities. And NMITE want a building that's architecturally interesting, designed to be shared, welcome and accessible, genuinely sustainable and future-proofed, that it does no harm, and costs are contained. So it came down to this: it's to be a single physical building that will provide a vibrant, inspiring and inclusive sports, food and skills community focal point for the people of South Wye. A community centre that houses the 3 stakeholders and that will enhance the local biodiversity, regenerate the lives of the people that own, use and visit it, is climate ready and causes minimal impact to the site and the planet. The space requirements are around 800 square metres, and there is a budget of 1.6 million. They set a priority that it is innovative, although there was some argument between the clients about that. It needs to be sustainable, inclusive, functional, and it needs to perform. It needs to blend into its surroundings, enhancing the biodiversity and landscape rather than detracting from it. But the building needs to be adaptable and have private areas and public collision spaces. Now, they love that term, collision spaces, and it means collision with interactions, not actually knocking into each other. But it needs to be loved by the owners, the users, and the community that it serves. Student participants are being sent to the TRADA webpage, so that's now where we hold all the information. And if you see along the bottom of the screen, that's where the short brief, the terms and conditions, how you register to participate, a link to the YouTube channel, and the webinar bookings for the series. And that is, with that, I would like to hand over to Scott McAulay, to as for a call to action.
Oh, thank you very much. That was, oh, I wish all the stuff I did in architecture school looked half as interesting as that. I'm really jealous. So yeah, thank you very, very much for the space to kind of issue a bit of a call to action. So this is going to be a little bit different than most kind of things around architecture schools. So we're going to look at the kind of a call to action about the agency you have as a designer and about having a collective impact because you're doing this in teams. So I'll introduce myself very quickly afterwards, but let's talk about why we're here first. So to really kind of hit that point home quite hard and quite fast, just to kind of take it from down the line, it just so happens that we're alive at the last possible moment when changing course means changing lives. So taking climate action is not just about carbon, it's not just about energy, it's literally about saving lives. So the thing is, everything we do now has a much bigger effect than what we do later, and the next 4 years are the most critical ones according to the IPCC as well. So just instead of doomism and images of climate change, we're just going to look at the hard facts for like 20, 30 seconds. So according to what was decided at COP26, the optimistic scenario is that we just overshoot 1.5 degrees. But the policies that were agreed on will at most keep us to 2 degrees and could go to almost 4. So that's a bit of a cataclysmic difference. So just to kind of, we all know around this is a difficult subject. I asked this question of a TRADA climate literacy group of students and staff to see what do people really feel when we talk about the kind of climate crisis and taking action and really just doing things about it. And there's loads of elements there that you probably resonate with you personally or you feel a bit familiar with. So there's lots of frustration, quite a lot of kind of overwhelm and anxiety, but that's entirely normal. So to introduce myself, I'm a climate justice activist, kind of first and foremost, and I've fused this into work with the Anthropocene Architecture School and climate literacy with Anthropocene projects, and I am a part 2 at Architype as well. But starting in 2019, I founded a School of Architecture in protest of the education system, really as it was being delivered. It was not up to tackling climate change. So fast forward about 2.5 years, and they got to the kind of literally the 100th talk of a School of Architecture with no building in 2.5 years during COP26. So it's now got to the point I can throw in audience participation with zero warning and people go along with it and enjoy it quite a lot now. But just to really talk about why we are here. So we've all heard that kind of the construction is the 40% industry. So about 38% of all global carbon emissions come from the buildings that we're building and how we use them. But also 35% of global energy use is from buildings and construction. So those are our kind of context. But how to try and put that into more perspective, I've taken that down to the scale of a single person for you. So with a little bit of help from Architects College Practice Guide, you can look at the average carbon footprint of a person in the UK is about 12.7 tonnes, which in comparison to the global is far too high. We are overshooting and using up far more than our fair share of resources. But at the same time, we need to remember that carbon footprint was designed as a metric to place the blame on us as atomized individuals, overlooking a kind of extractive carbon economy as well. We can then scale this up to the impact you can have working in construction, in architecture and design. So then you start to see what the impact of a small practice and a large practice. But if we take this even further and we look at the actual project impacts, the average large project has the same impact roughly about 196 people. So that's a bigger impact than our entire audience tonight is going to have in a single year on one project. So if you take this sort of learning you're going to do in this design competition into every project you go into in your professional careers, you can have an incalculably huge impact overall. So really just to stress that what you do right now and everything you do in practice has an incredible impact and can be positive as well. So just to talk about agency as well, because we can all do a multitude of different things. We have almost total control over what we can do ourselves, what we can choose to do. We can then look at the influences our choices, decisions, our actions have, and we can then go all the way into that kind of community of communities and the kind of systems of systems. But there's nothing stopping you right now in kind of contacting a head of your School of Architecture and asking if you can be taught more about how the climate crisis actually intersects with your work. There's nothing stopping you joining a group such as the Architects Climate Action Network or looking into Architects Declare Professionally, and you can do all sorts of different things there. So just to put into context what kind of one person with a little bit of a kind of mass panic around climate change and a bit of a thing for climate literacy can do in 2.5 years. So this is what the impact of the Anthropocene Architecture School looks like thrown at a world map ignoring that I've also spoken for Australia. So every single person in the audience could be doing this. There's nothing special about how I do this and what I do. Every single person watching this could be having as big an impact or even bigger and better in a collective or a group as well. So to look at how we can be doing that, even with this design competition, people make decisions around different aspects. So to look at a kind of behavioral economics point of view, there are only one out of those 6 things we can actually affect. So we can affect how information is presented. So your projects can actually be an education tool, they can be a persuasion tool, but we can also create new norms and look at kind of conducive environments or infrastructures. So I should only be about 60 seconds more. I might have overshot my time just a little bit. But what we really should do, we've been asked to give you something to look at that will help. So what I'm going to ask you to do is to look and learn beyond architecture and beyond the Anthropocene. So everything here is linked, but this is just a slight insight into what it looks like to go beyond just sustainable, to look at what's possible and to look at it from backgrounds that we've not been taught in architectural school and what's really a fantastic different way of looking at the world we're currently working in as well. Because what we really want is for you with this competition to really change that mindset, that paradigm, because sustainable is aiming for zero. And when the planet's in the state it's in, we can't just be doing zero harm. We need to be regenerating that planet. Our projects need to start to heal our natural environments. And you've got an amazing opportunity with this competition to learn how to do that and to bring it into all the work that you do again in the future. So one kind of part of this is I would invite every person here to watch this incredible illustrated video that really imagines what that future could look like. So what would it look like if we took climate change seriously and addressed it with the scale and the magnitude the Intergovernmental Panel on Climate Change has asked for? So I was kind of end on one of my favorite quotes of all time, because it's really quite kind of poignant and resonant with what we're doing. Because one of the challenges that we have kind of as a society, as designers, that we really need to be able to imagine possible and delightful versions of the future, but not just utopias and where things actually turned out okay. So we need to start imagining futures where our work can have a positive impact on the climate crisis. So that's from Rob Hopkins. And I will wrap up there because I've overshot my time by about 2 minutes. I'm incredibly sorry. But thank you again very much for having me.
Thank you so much, Scott. And I'd like to invite Harsha and Mohit to upload their presentation. And just to say thank you, Scott, because we asked you and offered you more time, and you said you wanted to give your time to other people to amplify their voices. And that's why Mohit and Harsha are here, and we're so pleased to meet them.
Thank you.
Thank you. And thank you once again, Scott, for the opportunity, and Tabitha. Hi, everyone. My name is Harsha, and I'm joined by my colleague Mohit from Decolonise Architecture. And we are going to be talking to you a little bit about global technologies. So who are we? We are a group of students and alumni who are aiming to tackle institutional racism and systemic bias faced within the architectural profession and its education. So we were launched at the University of Bath in July 2020. And today, DA works with universities and institutions across the UK towards our goals of implementing long-term change in tackling architecture's implicit biases. So what does it actually mean to decolonize, and in the context of education? So it's to examine these structures that exist within institutions and to challenge the perspectives that we have been taught and those that are passed down. So these challenge perspectives, or these Western biases, are evident in the Eurocentric perspectives of the history curriculums that we are taught across architectural education, and the consequent subconscious bias for Western design styles in architectural graduates. So how does decolonization actually lead to and affect climate change is the question. So since DA started, people from around the world reached out to us and pointed out that despite living in Asia, South America, etc., a large focus of their architectural education is on European and North American architects. So colonization is this direct result of Western imperialism, born from these ideals of the 17th century of enlightenment that centered whiteness as the default. So this very narrow narrative was enforced globally with no respect or no regards to culture or environmental contexts. And as a political tool, architecture explores these accelerated carbon emissions caused as a byproduct of forced migration, as a byproduct of colonial technological practices, and hyperurbanization. So this is an example of Jakarta, which is today a global e-commerce leader and also the fastest sinking city in the world. So as Jakarta has rapidly grown, the nature of its land usage has changed. Where once there were low density housing and commercial districts, these have now been replaced by high density, high rise office towers, hotels, shopping malls. And these new developments now draw vast quantities of water every single day from deep wells drilled 100, 200 meters below the surfaces. The rapid urbanization has then placed stress on the city's limited groundwater resources, reducing the height of the groundwater table and drying out the deep layers of soil underneath, leaving them vulnerable to collapse. Now, this in turn has made the upper layers sink, and combined with the sheer weight of such new developments has been the main cause of subsidence.
Thank you, Harsha. Hi guys, my name is Mohit. And so continuing from that, this unfortunate misrepresentation that we have that the skyscraper often the American skyscraper is this benchmark for success and metropolitan progress. It's kind of led us to forget the fact that this success will not take the same form all across the world, and metropolises they're inevitable, but it would seem odd that they appear so similar despite the climactic social and cultural differences in the cities across the world. So let's take the case study of the Al Bar Towers in Abu Dhabi. They're a set of twin towers where this kinetic facade opens and closes during the day to reduce solar glare and optimize natural light. And it's a great example of innovation in architecture, and it's got this striking kinetic facade. And this scheme was inspired by the traditional mashrabia, which was this perforated screen, which was used for the same purposes as providing privacy. But it does raise quite a simple question that why is there in the middle of the desert a completely glass facade behind it in the first place? If architecture should first respond to its site's constraints before anything else, then how can we justify similar buildings in wildly different environments? One way to look at this is by proposing a hierarchy of how we respond to the site. For example, start with the site constraints, the macro, work with what you have, which could be things like aperture sizing and the orientation of your building, and then fine-tuning it with the mechanical and electrical side of your proposal. So it's no good having the world's most efficient venting system if the fundamentals do not help optimize the sustainable performance itself. And a part of the issue arising is this trying to conform to Western ideals, and Dubai is a paragon of this. It currently ranks as 4th in the world for the greatest number of skyscrapers, which are, I think, buildings over 150 meters tall, and it's got 215. And New York is the next one above with 297. Now, a key difference between these two cities is their climate zones, which seemingly have been disregarded in a bid to make it look as if it is this symbol of success and progress, which doesn't always have to be the case.
So then the question becomes, how do we actually learn from the vernacular and still stick to modernism? So this is an example of the Yadong dwellings from rural China. So these have been traditionally carved into the hillsides to make use of the cooling properties of the thermal mass that this earth provides. Now, the image on the right is a modernized evolvement of these Yadong dwellings. These are still predominant across most of rural China, and these still share a face with the hillside. So this image on the right is also of a winner of the 2006 World Habitat Awards. These are a self-built project. These are over 1,000 sustainable dwellings built in the Loess Plateau in rural China. Now, this self-built project encourages awareness of land and environmental conservation, while the traditional skills of these Yadong dwelling construction techniques have been passed on to the younger generations. The question then is also, how are these effective with today's more complex needs? Now, these new modernized Yadong dwellings are environmentally, socially, and economically challenged. And these three, as a result of being self-built, are local solutions for local problems. Now, the first is the use of the local topography, which reduces the materials used in construction, and all of the other materials are sourced locally. Socially as well, these involve the community at the very start of the project, and economically, young people are encouraged to stay in the area, which then boosts the economy.
So where can we move forward from this point? At Decolonise Architecture, we put out on our social media platforms a segment called Technology Tuesdays, where we highlight a traditional style of construction technology from countries around the world. And because when we look at vernacular building techniques, there's often this, they're viewed through misty eyes and this sense of beauty and nostalgia, like, look what we used to be almost. However, this does not have to be the case. And as they are some of the most sustainable techniques that we have around, because of during their inception, due to the lack of fast transport or the internet, material discoveries, and people were limited to what they had in their immediate surroundings. So it would be naive to say that, for example, a very simple hut would be the solution to all of our problems. But the key takeaway from this is that we need to adapt, not replicate. There is nothing to say that these techniques cannot be adapted to suit today's needs. And architecture has reached the advances of today due to evolution in technology. And what we need to teach students is that the vernacular construction techniques, we need to teach them these techniques, but then also supplement them with contemporary practical interpretations. A good example of these are the Malachy wind catchers in Egypt. These are, these tall towers that would draw in cool air and cool the insides of a building. And they're an excellent example of passive cooling. However, they may not be the most suitable today because they are these fixed structures, and we may need to optimize them by, adding closable vents or tackle the issue of pests, for example. But another, on the flip side, NLE Studios reinterpreted the floating structures of the Makoko floating community and build a flexible floating school. So that is the interpretation style that we are talking about, where taking the first principles approach that came before us, and then see how can that first be used to address our needs today. So to wrap up, where does this almost leave us? Where it may seem that the current need for tackling the climate emergency creates this kind of trade-off between the sustainable construction techniques and the demands of today. But however, this does not always have to be the case. What we would like you to take away from this is that if we implement traditional construction techniques, but then also adapt them to today's needs, then there is no reason why they cannot first provide a much more straightforward and sustainable solution for our problems. Because in a world where we're all moving towards identifying our own identity, there's no reason why architecture cannot do the same. And so if we look at what's around us first and then incorporate that into our construction technology, then we can create a much more responsive architecture for today's needs. Thank you.
Thank you, Harsha and Mohit. Yes, so looking back at old traditions. Pablo, would you like to start sharing screen? So Tomorrow's Timber, I come back to this book time and time again. And last year we were lucky enough, PUFC sponsored the challenge, and we were enabled to give out some of your books. Pablo, it's
great. Thanks, Tab. Yeah, I see we have a tight schedule, so we'll plunge in deeply and directly. I'm a senior lecturer at Delft University, and indeed, as Tab mentioned, I wrote the book Booming Bamboo, and last year I published Tomorrow's Timber. My talks are sponsored by PUFC, from which I'm very grateful to be able to spread the knowledge about timber building and the importance of sustainable forestry, obviously. Actually, my personal drive to write the book Tomorrow's Timber was about, I'm architectural engineer from background, and I've been specialized on bio-based building since my finishing my PhD the past 15 years. And every time the same questions keep coming up from architects, and I dove into those and covered most of them in the book Tomorrow's Timber. Today I'll especially focus on the why would it be smart to use timber as a building material? And as Scott before already mentioned, it's very interesting that we are all working in a built environment, because the built environment is a big part of the problem related to resource scarcity and to climate change, but it is also therefore a part of the solution. So we're working in an industry which has major impact, which Scott clearly showed when you look at project level. So the built environment is very resource intensive. Almost half of all our materials used are applied in the built environment, and also very much related to the greenhouse gas emissions. The numbers just differ a little bit, but almost 40% of our greenhouse gas emissions are related to the built environment. And of this, about 1/3, so 39%, and 1/3 of it is related to the embodied carbon of the production of building materials. So if you take into account that just the concrete and cement industry has more CO2 emissions in a country such as India, and the same applies for metals and plastics combined, you see that, embodied carbon is also an important part of the puzzle. Then I always laugh of all those technocratic solutions that we sometimes find. I came across this one that was very interesting. It is a super big metal machine which sucks CO2 out of the air and puts it under the ground. Well, using a lot of energy during the production. And if we just keep it simple, this is actually what plants do, what trees do in photosynthesis. And as a bonus, you get a building material, or you get paper, or a very useful resource. So sometimes we make ourselves very difficult. And if you imagine that half of the wood is consisting of carbon, which is basically biogenic carbon coming out of the atmosphere through photosynthesis. So I go deeper in this part in a second, but as also the previous presentation showed, our whole building architecture is focused on non-renewable materials, all the skyscrapers with concrete and steel. And in the past, we did build a lot more with timber. Actually, in the Middle Ages and before, we only used bio-based renewable materials, reeds, timber, bamboo, leather. And we also see this in the heritage, right? There are ancient houses in our old city centers covering a lot of timber-bearing structures. And we can even go back further, like the stave churches in Norway, about 1,000 years old. And looking specifically at the UK, some very old, the oldest churches, actually, the oldest church in Europe that I know of, building that I know of in Europe, is in the UK, and it's this one. It's Greenstead Church, indeed, a millennium, more than 1,000 years old. And the oldest building that I know of, just talking about durability of timber, right? This is one of those timber myths. If you design a building well and keep timber able to keep it dry and to ventilate, then it can last for 1,500 years, like is in this temple in Japan. So it's really also a design challenge. You just need to know how to design in the right way. So durability is one of those timber myths that you can easily dispel. But this is what I was talking about, right? So from the Middle Ages, we use a lot of bio-based materials, including timber. And then the Industrial Revolution came, and it was substituted with concrete and steel, later also plastics. We've seen two small rises again with the invention of glulam and of panel materials. And luckily, the last 10 to 20 years, with the introduction of mass timber, we see a growing interest in timber building again. And it's important because it can help meet climate goals. So what's happened the last 10, 20 years? So in the past, we have had timber, tree resource being used for energy, paper, and then timber. And what we have seen now the last 10, 20 years, that there's a whole range of new high performance materials, timber materials being developed with very high efficiency in the production. So a big part of the tree ends up in a mass timber product. and it ranges from various building products. So the combined name is mass timber. So this relates to cross-laminated timber, CLT. It relates to glulam. It relates to laminated veneer lumber. I can't get into detail now. This is where the book goes in deeper, or my longer Tomorrow's Timber talks. But basically, I describe it as, I don't know if you have this in the UK, but in the Netherlands, it's very popular, kapla. And it's a very uniform, simple wooden piece in uniform strength and dimensions, and you can build very cool stuff with it. So what mass timber is kapla for grown-ups. You can make, because all the elements, you know the strength, you know the dimensions, you know the stress codes, so you can even make parametric designs with it, such as this the Swatch headquarters in Switzerland by Shigu 1. Also, of course, rectangular forms. This is the tallest timber building, mass timber building so far, 86 meters high. Giving the discussion in the previous presentation, you could wonder, do we need mass timber skyscrapers? Well, I don't know, that's another discussion, but at least it shows the potential and the strength and the uniformal high performance of mass timber elements. What you see here is glulam. You see CLT slabs for the flooring and the walls, and thermally modified cladding. So total bio-based construction. So this is what it looks like from the outside. And this really opens up. Mass timber is very interesting because of the prefabrication possibilities. So you move all the activities not from the building site, but you do it to the factory. And this has many advantages in terms of quality, and also the pace of construction at the building site itself. To give you a quick idea what cross-laminated timber looks like, this is one of the most important mass timber products. It's basically made just from ordinary softwood from European pine forests. You see they are laser graded, so you know exactly how strong these are in terms of strength class. The defects are taken out, and then those elements are glued in a perpendicular manner, three layers or 5 layers or 7 layers, always an odd number, to have maximum strength in both directions. It can be up to 20 meters long. And what you see happening here is that all the fittings and all the sleeves and all the openings for doors and windows are already done in the factory. So everything is done with seamless precision, and then these elements go on the truck, and then the building site becomes an assembly site. You can directly erect this with a lot less machinery use, less people on site, and less nuisance. This is a project in London, Dalston Works, by Walt Thistleton Architects, and I want to show you a little bit more about it, because very funnily, this project doesn't show any of the timber that's being used. It is covered with bricks. At the insides, the timber is also covered. So they chose here for timber, but therefore I really think it's a good example, because here it's not about showing timber. It's just a mainstream, ordinary concrete building, but it is timber. So it has very low CO2 emissions, and it had some advantages because of the prefabrication, because of the timber being 5 times lighter than concrete. And because of this, the building time was 9 months quicker. They also could use smaller cranes. And interesting enough, here you see a tube, but there is also a tube going underneath the building. So it needed, it couldn't have a pile foundation, and needed a raft foundation. So it needed a light construction. So this building wouldn't have been possible building in heavy building materials. Also, the building site in the middle of London. So here you don't want any nuisance for all the neighbor, the surroundings, neighboring surroundings, related to truckloads, related to noise. And interesting enough, it was calculated for this building being erected in timber, only 100 heavy truckloads were necessary instead of 700 truckloads in concrete. I mentioned this, less material, less utilities required, less people on site as well. And also people working on a timber site, they really like it. There's less noise. You just need a simple, I don't know how you call it, drill thing that's easy. I think you know what I mean. So you also hear that from the workers that they really like to work on a timber building sites. And if you add all of this up, we know at this time we don't have a carbon tax yet on building materials. It should come very soon. As Scott pointed out, we really have no time to waste. So we should really tax CO2 intensive materials. We cannot avoid it, but still at this point it's not done. And then when you look at, for example, CLT, it has higher material costs still. This is a comparison for a typical 7-story apartment building in the UK. But you see, at least because of the faster process, you win back in main contractor items, and you have a lower cost for the foundation because you have the lighter foundation. So altogether, such a project can be about 1% more expensive if you design it well, right? If you don't take into account all these prefabrication possibilities, then you don't win it. If you have a concrete building and start to recut it and redesign it in timber, it doesn't work. From the start, you have to think and design in prefabrication. Then you can be very close in terms of costs. This is also what we have seen in the skyscraper, Mjørstadnet in Norway, which I just mentioned. It's 86-meter tall wooden skyscraper. Sweco did some calculations on that, and they estimated that indeed it was, because of the faster construction time, only about 1-2% higher building in terms of building costs for the bearing structure itself. Largely won back because of the faster construction time. Okay, so that's a quick introduction about the potential benefits of mass timber building. And today I don't go into details about fire safety, about acoustics. These are covered in my larger CPDs that I do together with PEFC. But I want to focus today on the 4 main reasons why timber should be used in light of the resource crisis and the climate crisis. Well, one is the low and even negative carbon emissions. I showed you this in the beginning of my presentation. Half of the weight of timber is biogenic carbon. Then if you look, for example, it's cross-laminated timber. I showed you the process. Then many people think, oh, that must emit a lot of CO2 because of the glue. There's only 1% of glue in CLT, for example, or the energy use. Well, if you look at CLT, in 1 cubic meter of CLT stores for the lifetime around 3/4 of a ton of CO2. And these light yellow circles show the emissions during production. So you see that the emissions are about 1/5 of the carbon stored in the CLT for the lifetime. So it's really not that high, the CO2 emissions during production. Also a lot lower than abiotic building materials such as concrete, bricks and steel. But the good part, the better part even, is you don't only have carbon stored in the built environment, you also obviously have carbon stored in the forests. And as long as you use wood from sustainably managed forests, then there is a constant carbon store in the forest itself. And every time when you harvest a mature forest, you should not burn the wood for energy production. No, you want to store it in the built environment. And then the built environment comes over time a cumulative carbon store as well. So you have 2 carbon stores in the forests, especially if you do more afforestation, which the European Union is planning, and 1 in the built environment. And then a building such as this, which is typically built in concrete and steel, becomes a carbon store. This is called, if you want to make calculations on your own, construction stored carbon. This is the metric that's often being used, and it's very simple to do calculations with this. In the chat, I'll put in an interesting calculator with which you can quickly calculate, also for the Southside Hereford challenge, how much carbon you're going to store in your design, as long as you know how much wood you're using. So this building, as I mentioned, typically this would be built in concrete and steel. And if you look at the CO2 emissions of concrete and steel, Well, you see that, and by the way, you can download and check this graph out with all underlying environmental impact data at this website, a Danish website. The higher on the pyramid you are, the more CO2 emissions per cubic meter. So you see here aluminium, you see here up at the pyramid steel, concrete is right in the middle. And here you see all the bio-based materials, including timber. So once you start building a typical building, which normally would have been built in concrete or steel, and you substitute it with timber, you also have the avoided CO2 emissions. This is the third lever. And very roughly, if you do all kind of average on all these various building materials, then you can say when you use 1 ton of softwood, so about 2 cubic meters, where you typically would use concrete and steel, you save an additional 1.5 tons of CO2. So you can make these calculations for every building. So this building, which I showed, is the Wood Design and Innovation Center in Canada. There's 1,500 cubic meters of timber. It stores about 1,200 tons of CO2. It avoids a similar amount. So in total, you have a climate benefit of 2,000 tons of CO2. So this is exactly what Scott was talking about. This has impact. And if you look at the bigger level, bigger buildings, and by the way, this building can be easily, you can imagine that these elements in the end of life can be reused. They will retain their value and have a second life. So the carbon, I'm convinced in 50 years, when this building might be reaches its functional lifespan, I'm convinced these elements will be reused. They just retain too much value, and the timber will be totally intact. If you look at a larger scale, this is a very recent opening of one of the largest mass timber buildings in Europe. It features more than 10,000 cubic meters of timber. And what's interesting, it's in Sweden. Also, the elevator shafts are not in concrete, they are also in timber. Also really taking advantage of the modular prefab construction. So this one was also 1 year quicker in construction time compared to traditional building. And it's a magnificent building as well. But here, if you look here at the climate benefit, if you add all the mass timber coming from sustainably managed forests just around the corner, and imagine how much carbon is stored in the building, how much is avoided, then you really have a huge impact in a mass timber building. And this is a very interesting study, which looks at if we are going to really transit to mass timber building, what could be the potential benefit? Well, if in 2050, all new buildings in our cities would be built largely in timber, then there could be in total 100 gigaton of CO2. Imagine that to keep within the budget, to keep within 1.5 degrees Celsius increase, we have 400 gigatons of CO2 budget. So this can already solve 1/4 of the problem. Of course, there are many other aspects where we have to look at, the transport industry, but here the built environment can really have an impact. So that is really a clear benefit related to climate change. Then the renewability aspect. I often get a question talking about timber. Everyone asks, oh, but it can be good because we have to cut a tree. But people don't ask the other question, where do bricks come from? Where does concrete and steel come from? You cannot regrow that. You can only get these out of very deep mines, and it won't grow back at all. But no one asks this question. But I understand it, because this is, and also we have had it in our childhood concerns, we think about tropical deforestation. And that is still an issue. But the drivers for tropical deforestation have nothing to do with timber building. Mass timber comes from Nordic forests. And the drivers for tropical deforestation are mainly commercial land conversion for commercial agriculture, for the meat industry, or to feed the cattle needed for the meat industry, or for large-scale infrastructure development. And ironically, 10% of the Amazon is deforested for mining bauxite to produce aluminium. So this makes it very important that if we use timber, we have to get it from sustainable managed forests. We have two very good eligible sustainable forestry schemes, PEFC and FSC. They basically have the same goals and meet the European Union timber regulations. PFC is a little bit more focused on softwood and has a larger area, but both, what they do is they check the whole chain of custody, from the forest to the sawmill, to the manufacturing unit, to the building site, that all environmental and social aspects are covered. But of course, the most important part is the forest itself. And here, these schemes safeguard the conservation of biodiversity, the needs of workers, of social workers, to retain the water level, but most important, that the carbon level at area level remains constant, at least constant. Preferably it should grow, but there should not be a diminishment in carbon and CO2 emissions. So looking at PFC, of course, this relates to our engineered wood being used, but it also relates to energy use. It relates to packaging, pellets used for energy production. So just make sure when you use the timber, you get it with a certification, then you're sure that you are keep maintaining and keeping all those sustainability aspects. Of course, it's related to many of the green building certification schemes. And a good effect is that in the Northern Hemisphere, the actual area of forest is increasing the last 30 years. So this relates to Europe and it relates to Southeast Asia. And here also it's expected the coming years this will increase again because of the reforestation plans of the European Union. But there's a net increase of forests in the Northern Hemisphere. And this, if you think about it, okay, UK doesn't do very well in terms of forest cover. Holland also not that well. But in general, in Europe, there's a lot of forests. And actually, there's additional capacity in this forest to increase our use of timber in the built environment. To give you an idea, the forests are a very important carbon sink. Every year, about 10% of the European Union CO2 emissions, including UK and let's go Europe emissions. Oh, this must be very sensitive, of course. But 10% is mitigated by just the European forests. And if in the coming 10 years, the reforestation takes place in a climate smart way, so really climate resilient forest, so enough biodiversity and choosing species that are climate resilient, it could by 2030 even be almost 25%, mitigate 25% of the European greenhouse gas emissions. And then looking at the forests, as I mentioned, they are increasing every year by about 0.3 million hectares per year. But if you look at additional capacity in the forest itself, there is an increment per year of 800 million cubic meters of timber. We only harvest 500 million cubic meters. So the additional growth is 300 million cubic meters. Well, this sometimes also is not in very easily reachable places, but about 1/3 of this is easily reachable, and we could ramp up by, and to show you the calculation, what this means, because these are high numbers and they don't tell you anything. So let's make it more concrete. So quite easily, you can, within the coming years, have an additional capacity, based on additional to the current harvesting of 70 million cubic meters of logs. Conversion to timber provides 30 million cubic meters. Well, if you take into account that a small apartment or a big, an apartment consumes about 30 cubic meters, a big house about 60 cubic meters of timber. So this means that in a sustainable way, based on additional capacity, you could produce about 1 million apartments or 500,000 houses per year. This is more or less the European need for additional housing. So there is really more than enough wood to ramp up the production based on mass timber, but it just needs to be specified. Well, the final two parts I go a little bit quicker in. These are, I think, the most important ones. Circularity. The reuse of elements, of timber elements. This relates to any building material, but because timber is so light and because it's easily workable, it's a very suitable material for circular material use. This is a project in the Netherlands which is designed for disassembly. So the beams are on purpose put on top of each other, that there are as little as possible protrusions. This is the building. It's built by one of the largest Dutch banks, the ABN AMRO bank. And also at the inside, there's a lot of timber being reused for a second time. For example, the flooring is being reused for a second time. The use of post-consumer wood is also very interesting in circular design perspective. This is another project by 3XN, a large architectural office in Denmark, in Copenhagen. And they have reused about 300-year-old beams in their really spectacular architectural office. So this is all carbon stored for more than 300 years. It gets a second life. And well, it's also designed for a disassembly again. Circular building can also be on modular level. This is a simple school in Amsterdam, which is going to be moved in 5 years in modules on the back of a truck to another location. But it looks from the inside and outside as a permanent school. So circularity is just about design. And timber is very fitting because of the lightness and the adaptability. And I always call timber double circular. One, because, well, first of all, you have to, if you design in a circular and with design for disassembly in mind, then you might have a building which lasts 50 or 80 years. Then if you do it well, you can reuse it in a second building. And maybe in the third life, you can chip it for panel production. And in the fourth life, maybe you burn it for energy, but I think in 100 years, this will be prohibited and you will use it for biochemistry or something like that. In the meantime, the forest has grown back 2 or 3 times. So that's a surplus of material that you can use again in the built environment. So in that case, this makes timber double circular. And I'm not against, don't get me wrong, I'm not against use of steel and concrete. They can be complementary to timber building. This is an example in Amsterdam where they use the demountable structure from glulam with prefab demountable concrete slabs. So some places you can combine them well, and they give actually pretty good architectural expression. But only when this significantly reduces the use of timber and make sure that also the steel and concrete elements are also demountable and are not downcycled and put under the road for highways or something. Well, the final aspect why timber is a fabulous building material has to do with well-being. And this is a real new field of education and R&D. It relates to biophilic designs, and you have some really excellent examples in the UK. I love the Maggie centers designed by various architectural offices. This one is from Heatherwick in Leeds. The Maggie's Cancer Centers, they are on purpose used with a lot of plant materials, but also a lot of natural materials inside. And you see there in several hospital environments that the use of timber, the visible use of timber, can help reduce heart rate, can help reduce stress, and sometimes even can increase recovery. This relates to healthcare. Obviously, it also relates to schools. There are some very interesting studies that show that kids in environments with more timber have lower stress levels than in the same classroom without timber, just with the concrete and plaster walls. And obviously, for office environments, this is also super interesting. It seems that office productivity of workers goes up because of working in an environment with timber and plants inside. So this biophilic design, which is what is called, is a super interesting new research field. And actually, TRADA and ETSADI at BRE are doing a lot of research on this. So you have a lot of good knowledge base in the UK about this. And you see, because of this, that timber buildings also score high in healthy building certification systems, such as WELL, where you have WELL Platinum certification, so the highest level for various timber buildings. And this also relates to BREEAM. The highest score ever, I believe, all in the world is, this should be outstanding, of course, is almost 100% in a fully timber building in the Netherlands, but also LEED score high. So this can be an interesting driver for well, investors that are interested in green building certification. So actually, the question should not be why wood, what would be the reason why not to use wood? It can be pricing, but that is where we need carbon taxing. Well, to wrap it up, I do see a lot of things happening in various countries where timber is really ramping up. France saying that all public buildings need to use 50% of timber. In Amsterdam is committed in 3 years that from 2% of timber use, we go to 20% of timber use. So there's a lot of stuff happening. Major pension funds in the Netherlands are fully investing in timber building. So the momentum is there, but there's still a lot to do to get there. And if you, for example, for Amsterdam, if this Green Deal is met, this really means a huge climate benefit. And actually, if you calculate about the value of this, 1 ton of CO2, 125 euro or 100 pounds more or less, you have a huge climate value that you can store in all these buildings and maybe finance this additional costs. And in the end, our cities will look better, they will be more biodiverse, and they will store carbon. And I think this is what we need and what need to be focusing on. Okay, guys, thanks a lot. There was a lot to take in, I know. There's always so much to share. I just want to tell you that PFC has made a pretty cool offer. If you like to know more about the book, which covers this, what I just covered, but also designing and building process aspects and costs, etc. You can get a 25% reduction if you order the book with this code, PFC 25% off. Okay, that's it for now. Thanks. And yeah, I don't know when we do questions. That's up to you, Tab.
I think questions at the end, so I'll come back after James. But yeah, if you could put any links in the chat, Pablo, that'd be fantastic. And the Enterprise Centre, which has used all sorts of materials that we wouldn't have expected in buildings. So James, Todd, and sorry, Malachy, McNamara, the floor's yours.
Thank you very much. Yeah, so we're going to focus in on one project, which I think kind of features a lot of things that we've been talking about this evening, and it's the building that we worked on at the University of East Anglia in Norwich called the Enterprise Centre. And what we want to do is sort of talk you through it. It was a competition, so this has a relation to what we're talking about this evening. We'll sort of talk you through the process and some of the kind of ideas behind the building. And I think particularly it tries to pick up this idea of, you know, how many different ways can you use biomaterials? This idea that we were just talking about, Pablo, about the idea of a kind of cascade of materials over time. So just a quick introduction. I'm James Todd. So I'm a work at Architype, and I'm a associate director in London for Architype. Also the project architect on this building.
Hi, good evening. Malachy McNamara, Civil and Structural Engineering Director at BDP. I would like to point out that actually this building, we started this, James, was 10 years ago, this competition.
That's true. Yeah, it is true. And it finished in, well, it completed in 2015, but because it had a kind of a long soft landings process at the end to make sure that it was working properly in about 3 or 4 years, we were still very much involved with the building until fairly recently to kind of fine tune it. So I think it's definitely part of its success. So it's worth pointing out that it was a competition that Malachy and I were involved in, but it was basically right from the beginning the contractor was brought on board, which I think was quite interesting. So we were kind of working for Morgan Sindall at that point at the competition stage and all the way through the process of delivery. So it was an OJU design competition. The budget was around kind of 11 million. It's about 3,500 square meter building, and a whole range of different kind of stakeholders involved. Essentially, it was a kind of building to kind of promote the low carbon adapt group at the university and bring together research in low carbon technologies together with startup low carbon local businesses. And the brief was a kind of fantastic brief that captured everything that I'm interested in as an architect. So it was looking at kind of long life and resilience and climate change adaptation. It's a Passivhaus certified project. BREEAM Outstanding, and then really trying to drive down carbon. So at the UEA, a lot of the sustainable buildings, there's a long legacy of kind of low operational design buildings at UEA, but they'd often relied on using kind of conventional high mass materials. So the challenge here is how can we use bio-based materials to kind of substitute out and still get really or better performance. And as part of that journey, we carried out a number of exercises. So the focus on embodied carbon, so it's driving down the embodied carbon, trying to create a kind of carbon positive building, looking at the kind of circular economy, so reusing materials within the project. I think we managed to get the old reception desk out of the Sainsbury's Centre from Norman Foster and drop that into our buildings, a bit of reuse amongst other things. And also, I think picking up on the previous speaker, just the quality of the environment. So trying to create a really high quality, relaxing environment that kind of supports learning and sort of business. This was the winning kind of competition entry. So you can see the kind of panels. You can see at this stage, we were already thinking about thatch, and we worked with a local thatcher, Stephen Lech, to kind of mock up the idea of actually taking thatch into the kind of 21st century with a concept of kind of prefabrication and modern methods of construction, and how we could kind of bring this traditional low carbon technology onto a modern university building, and what a statement that would make about the region and the local materials. So a kind of initial exercise, which I think is really excellent exercise to do in any project, is actually to look at what you can get locally and go out there and kind of investigate that. So we kind of carried out that at the competition stage and looked at what materials, so kind of flints, reed, thatch, straw, hemp was grown locally, and then also the kind of forest in terms of the Thetford forest, so which we'll come on to in a moment. And in the press at that time, there was a kind of refocus on thatching within the region, and kind of that was really becoming more prominent. I think it featured on television. And we got talking to Stephen Lech, and he was really inspired by his trips to other European countries where thatch was seen as a kind of integral part of modern construction rather than just being a traditional technology. And he really wanted to kind of promote its use in the UK. And so that became a kind of integral concept of the project. So can we create these kind of thatched wings, a really kind of simple concept that celebrated this bio-based material. And that developed into a kind of scheme proposal with a kind of U-shaped building with the wings orientated for Passivhaus to make sure we were getting good kind of solar orientation, set in the context of Earlham Parks or a historic building context, with the two wings, one for kind of learning, one for business and low carbon industries, and then in between a large space for kind of interactions, social work, kind of lectures, events, and workshops. And you can see on the section, the kind of concept here was developed to enable really great solar shading. So we worked with the climate change kind of department at the university to look at climate resilience and future, and developed a section that really responded to that. And then also that relates to the kind of Passivhaus strategy. So the building was a Passivhaus project from the outset, and you can see some of the principles that were this is at the competition stage. So the idea of this sort of duvet layer, so a thermally continuous layer of insulation wrapping the construction, really great consideration to air tightness, looking at the use of triple glazed windows, mechanical heat recovery ventilation to make sure that we're not losing energy through the air that we're using to ventilate the building. And we investigated a palette of materials, building on some of the other projects that Architype have been involved with. We explored Brettstaple, we'll come back to that a little bit, which is a kind of mass timber panel without glue. We looked at kind of Larsen truss, which is a kind of way of using quite simple timber stud technology to create a really thick duvet layer of insulation. And then we looked at the thatch and the render kind of cladding technologies and how that could kind of come into an interior palette of materials of the building that would kind of really celebrate this sort of bio-based construction.
I think, sorry, James, just on that one, I think Pablo picked up on it. It's actually very difficult to convince clients that timber can be used. And this was a university building, which had a very tight budget. So we wanted to use timber, but they were always worried about how expensive it was, where could we get it. They were very worried about fire spread, being a university building, acoustics, because there were lecture theatres and working offices. It was a combined building, and durable. I mean, they university building wanted a long time. So we had to answer all these questions all the way through. So it wasn't a given at all that it was going to be timber. And in fact, we actually designed a steel structure with timber floors. So it was a bit of a sort of behind discussion to get to timber as material. And I think you mustn't forget that, as Pablo also picked up, we need to make sure that we're using the right material in the right place. We're not just using timber for the sake of timber. There are lots of different, concrete is an amazing material in some places, so is steel. So be very clever and careful about how you specify it. And also you would have picked up there that there's different types of timber, which was picked up earlier. You do just get sawn joist, which are very cheap and easy to get. CLT is another step, as more machinery, it does cost more, and the costs go up as you go to LT, LVL, all these expensive things. So be careful how you specify the timber and watch out where you put it, make sure it's put in the right place.
That's great. And I think that's probably one of the reasons why, in fact, we ended up with it was a kind of hybrid approach, but using actually a lot of quite simple kind of construction that would be more similar maybe in a kind of house in terms of simple 140 deep timber studs that were kind of pretty standard to form the walls, and kind of actually minimizing the use of glulam and engineered timber because of the cost parameter as Malachy said. So that's
So you're mute, James.
Sorry, I think I'm being muted by the host. That led to a kind of picture where we tried to capture that at the competition in terms of the level of carbon sequestration within the building. And I think, again, this is a kind of interesting point here. You capture all this carbon within the building, but the end of life is important. So, in the end, that carbon has to go somewhere. I think it's absolutely correct to say that the majority of that will then cascade down and become other timber panel products in the future. But it's just, I think there is a question about efficiency as well, so we can't lose sight of that. So I think there's benefits putting bioproducts in, but I think also here the aim is also to deliver a kind of efficient solution that was cost effective.
So we won the competition, and then we needed to describe to the client how we're going to get local timber into the project. So it's very important that it's very easy to just import timber from Europe. There's tons of it and it's very good, but we wanted to get local timber. So we went around to local forests. There's plenty in the UEA area in Norwich, North East Anglia. And we went to Thetford Forest to look at some timber. And I think we had a guy called Daniel Stutska with us from Wood for Good. And there's us selecting timber, so to say. Had to be local timber, so that Corsican pine and things like that. And we took some samples away and it was all tested. Move on, James. Then it was a good day out, I must admit, seeing how we then produced a design, which was based largely on trying to get local timber into the scheme. So we produced the whole design using local Thetford Forest timber. And that came out to be very expensive. So we had to sort of downgrade it. And one of the ideas we thought of doing was using a lot of Brettstipple panels, which are a product from Germany, which is a very sort of mass timber but low tech solution. It's very easy to manufacture and build, but we did struggle to find suppliers. It's a very low tech thing, but on this scale of project, it was very difficult, especially in the UK where we do struggle with timber skills. We did manage to get some timber into the product, so we got sort of glulam frame going in the design. And we managed to convince one of the contractors to use the local timber for all the stud work. And the problem we have that is, James, you can go next slide. Yeah, so this is the solution this is local Thetford Forest timber, which has been treated and cured and then brought back to site. It does suffer slightly from what's called sort of blue gene. You can see a little pattern on it there from sort of a fungus material, which is not a problem at all for timber, but it does look different. Some clients don't like it. But this was a successful product. We managed to get local timber into the building, which was fantastic, on budget, which is probably the important thing. And here's an image of the local studwork timber, and you can see the glulam frame behind is the imported glulam frame.
I think it's one of the examples, another example of the blue stain. There's a great PhD which says the problems of blue stain in timber, brackets, excluding Corsican pine, close brackets, which we mentioned we're continually bringing up with the client to explain why there was slightly blue mold, but it wouldn't affect the structural properties of the building. And these are some images of the kind of frame going up. Obviously, there's a lot of kind of consideration about detailing on this in terms of passive house, to make sure we can kind of maintain the airtightness line. So the frame kind of sits inside the duvet layer. And then we had very small, I think they got called Coke cans in the end, which kind of connected from the frame into the walls to kind of create the stability and structural connection. And then, Malachy, do you want to say something about this?
Well, again, here you can see lots of, but this is a passive house, so you can see all the steels going in. Lots of types of timber here. So you've got the glulam frame, and you've got the sort of OSB panels on the side. We also got what's great about timber is a lot of the connections can be manufactured off-site. So the image on the right there, you can see some beautiful connections pre-made, and that sort of promotes the off-site manufacturing, or the sort of design for manufacture. You get some beautiful connections. So the good thing about timber is, although you can hide it as some buildings, but it's quite easily exposed, and you can make some very neat connections and neat junctions that help with making a passive house airtight, which is very important.
I think you can see here, so the concept here was the panels themselves created the airtightness there, so rather than use plastic, so we taped an OSB 3 for airtightness to minimize fossil fuel materials. You can see this separation very clearly here of the kind of structural frame with the kind of Coke can connection. So you have this kind of independent, continuous thermal envelope wrapping around. And then we also had warm cell, so cellulose blown insulation. So the insulation itself was then a bio-based product as well, which kind of performed really well and was great to create that continuity.
So sorry, Jane, just go one back there. What did happen on site, we had designed a timber ground floor to sit above the finishes of earth, and they discovered that on site there are a lot of sinkholes, so it was virtually impossible to do. So we had to change the whole foundation design at the last minute, but we changed it to a concrete slab, which was sitting on top of the insulated raft, so it's almost part of the passive house duvet layer. The clever thing about the concrete slab is it is just a concrete slab, and they ground polished the floor. So in photographs later, you'll see that actually what you see is a shiny floor. It's actually the ground concrete. It's an amazing finish.
I think and that's one a good example, I think, of where materials can be complementary. So we did a embodied carbon study on that, and because we managed to omit the floor finish and replace it to the structural slab with just the floor finish for 100 years, it meant actually the actual carbon penalty is very low, and it created this really resilient, durable floor with a natural expression of construction within the building. So I was going to talk a little bit about the thatch panels. I realise time is evaporating here, but we'll go as fast as we can. So again, the concept here was that you had, it was a big building and a big challenge really for the thatchers we found here to take on. So the concept was developed that the contractor basically, we would design and they would produce these kind of carrier cassettes, which would then be fabricated and then shipped out to all these different barns and workshops across the region. And then the panels would be thatched in the barns and then shipped to site and essentially kind of hung onto the facade and then brought together, which was kind of great for thatchers because they kind of meant they could do it kind of when they weren't working on site or when the weather didn't permit. This is an example of a kind of thatch scarf joint. So this is how we kind of brought these thatch panels again on the facade. We tried to do it, I think, in one whole section, but it was too heavy to move. So we had to kind of create this joint in the middle to get it to come together. And this is the first prototype ever made. The Hoover's here to suck the eggs out because the chickens had got in there within the barn. But you can see the kind of seamless appearance that was achieved from bringing together kind of 4 panels here, including a kind of corner section. This uses hazel sways, but in the end we did use actual kind of steel rods with stainless steel wire for the strength. This is an actual picture of them kind of cutting the reed for the project. I don't know, they're not necessarily the most efficient vehicles from a carbon perspective, but it was definitely local product on the building. And then here's an image of some of the thatchers kind of working in the barn and what that then looked like when it got integrated onto the building facade. So there's this real kind of sense of kind of, you know, tradition coming together with kind of modern materials. And again, celebrating things like the local flints from just down the road, different materials. So the facades were done in straw because it was vertical and then shedded water better, whereas the roof sections are done in kind of reed. Again, you get the sense.
The thing about those modular facades is, don't forget, virtually all modern buildings these days are done what they call, I love it, modular glass panels, modular systems. And here we developed a modular thatched panel that could be manufactured off-site and brought onto site. So it's a good win-win there for us.
So Stevie did spend quite a long time on a cherry picker with a garden shears, trimming it in the end to get the seamless appearance. And there's also some really great examples of projects we kind of reuse. So one day in a site meeting, I think one of these guys in the States said, oh, there's all these weird boards in the basements of various plant rooms across UEA. And it turned out it was the old science desks from the Lasden University building that they'd taken out. So we took a sample away, got it kind of machined up, and it turned out it was a Roco. And so it was reused as kind of cladding on the building. And it looks absolutely kind of stunning material. Bit of a problem with the DRE certification, but I think that's kind of true sustainability rather than tick box. And then again, this sort of idea about what the environment this then creates. It creates an incredibly calm environment. It's really great for productivity. And the kind of palette and bio-based materials, including things like kind of clay boards, panel boards using kind of wood stranding, blown cellulose, actually acoustic insulation as well, which is kind of really effective, avoids the need for kind of mineral walls, etc. So we try to capture this kind of bio-based technology in one building, which creates this really calm, peaceful environment. I mean, personally, I found that when I went there, even though I was the architect, whenever I went in the building, when it finally got near completion, it was very calm. You kind of felt your kind of heart rate actually kind of dropping. And part of that was the fantastic views, looking out over the parkland from the spaces and the light kind of coming in a controlled way. And this was also tested through POE. So this is a kind of a bus survey, a building user survey, looking at how people kind of responded to building. So people felt it was healthy, productive, enjoyed the quality of the environment, the design and the image that the building had. And the delivery of this was, again, I touched on this, after the building completed, there was a whole program then of fine-tuning the design with a budget, which I think is really important on projects to make them successful. And I'm going to zip through these, but here was just an example of a process we went through to kind of really simplify and optimize the control system. So we've used all sorts of different ways of kind of dealing with managing the issue about whether windows should be open or closed in the Passivhaus building. Generally, you can open the windows in the Passivhaus project. But here was the idea that you'd have kind of a nudge panel to suggest to people when it might be a good idea if they wanted to think about closing or shutting the windows, but not automating that. And then you get a scale of the kind of energy performance in reality. This is actually a very small person and an even smaller radiator next to them. This is the kind of typical size of radiator within one of the rooms on the project. And the outcomes of this in terms of energy were great. It's very unusual for a building to perform as it was designed. So you can see here the predicted energy use in terms of electrical and heating, and then how close that was actually to the measured performance of the building. You can see it's got a deck A. I think we've now got a 6th deck A in a row. Generally, what happens with projects is that the performance kind of deteriorates. But in this case, the performance has really stood over the test of time, which is fantastic. And then in terms of carbon, this project was quite interesting that it had an actual deliverable target for whole life carbon. So that's carbon to build a project and operate it, given to the contractor as a target. And so we want this to be 500 kg. You've got to remember that this is now being contracted 6 or 7 years ago. But when you compare that to the kind of current REBA and LETI targets, you can see that we're still kind of doing really well against the kind of LETI 2030 target here. So we're well below that still, even now. What does this mean in aggregate? It means a big reduction in impact. So when you look at combine, this is a graph showing carbon over time You can see in a conventional project, even now built to current regulations, big hit of the carbon emissions at the outset of the project, and then the kind of operational emissions accumulating with the kind of UEA, and we're taking a passive house and low carbon approach. You can see much lower impact at the outset and then lower impact over time. And it's a sort of 70 or 70% reduction in total impact. Again, worth pointing out that the climate crisis is now as well. So focusing on operation, the benefits of that only accumulate over time. So actually what we can do now in terms of how we build projects is really important. So yeah, I think it's worth saying as well, picking up on this thing about, do you want to talk about this, Malachy?
No, apart from it being a fantastic evening out, we did not expect to beat the Cheese Grater as the best building council officers award. So you get a gold award for the most sustainable, and then we actually got the prize of the night for the best office award, which was fantastic. I'm really upset by the architects, as you can imagine.
A triumph of wood against steel.
Yeah. So this is a good example of the BCO recognizing that timber in the workplace is the future. And this was 2017, I think.
Yeah. And then finally, I've just stuck a few little kind of resources. I think people may be aware of the ACB already, a few other kind of resources that we use, the ASBP. If people are interested in the thatch, there's the kind of few links to the thatch here. This is a classic text on thatching, which is fascinating. It shows all the traditional techniques of how you do it. In wood, I think they actually did the circular columns. They were from UK timber, finger jointed together. And then also, if you want a virtual tour of the building, it's still in the COP26 building pavilion, so people can log on and have a look and look around. Thank you very much.
Well, gentlemen, that was absolutely fascinating. I know there's lots of questions in the chat. What I'm going to do is just share screen and round off a few, and then just quickly come back to chat to questions. And you've brought us bang back on time. Are you seeing what I'm seeing now, which is, you're not seeing my presentation on top, you're just seeing a slide? Yeah. I'd just like to say thank you to our speakers, Scott McAulay, Harsha Gore Mohit Buch, Pablo van der Lugt, James Todd, and Malachy McNamara. And I hope they have given you so many ideas for the Southside Challenge. I've popped the links in the chat, so I won't go through that slide. We have a whole series of webinars coming to you, and if they're as good as tonight, you're not going to be able to afford to miss them, but they are all up on the YouTube channel. Next, on Thursday, engineering value and whole life costing, looking at contracts as well, which was interesting to pick up on tonight. And our speakers will be Kirsty Conwell-Skinner, George Pleasance, Alex and Carol, Louise from IPI, and Nicola Jackson. So again, we're going to bring you things that maybe we're not going to be expecting. And this is the Timber Development UK Southside Hereford University Design Challenge, which we're bringing to you in partnership with the Passivhaus Trust, Edinburgh Napier University, and NMITE in Hereford.